they don't want to do the detailed energy audit. Instead of that, suppose if you take the example of the commercial building or the jewelry shop, if you go to the jewelry shop, you will find the major electricity consumption is in air conditioning as well as a lighting systems. So there either they can ask you to do audit only related to the lighting system or related to the air conditioning system. So on that come under the targeted energy audit. Or even suppose if you go to any thermal kind of the industry where maximum steam is being used, so they may ask to do the audit of only boiler system. So that come under the targeted. And somewhere in most of the industries everywhere across, you will find the compressed air system. So we need to do the audit of the compressed air. Now in the compressed air also, suppose that industry requirement of the compressed air is a 4 kg per cm square, and if it is being used at a 6 kg per cm square, so if you reduce the compressed air pressure by 1%, again there you can consider electricity of the 5% almost. So these are some of the tips which we need to understand, and by that you can conserve the electricity. Now next is a third type is detailed energy audit. Now this detailed energy audit is divided into three parts. So first one is a pre-audit, next is a on audit, and third one is the post audit. That means suppose if you want to conduct energy audit of any industry or even the commercial organization, commercial establishment, or your college. So first there should be some understanding between that energy audit team as well as the college, industry, or the commercial building. Once you get that understanding or work order, immediately you should ask some data which is required to plan that energy audit before reaching to the industry. That all come under this your pre-audit. And once we prepared with all our the baseline calculation, energy bill, invoice, the calculations, and what type of the instrument we need to use inside that energy audit, that will be prepared, and accordingly you will enter into the phase 2. Phase 2 actual measurements are being taken, because under this your phase 3, suppose the motor is there, we need to measure the how much current it draws, how much voltage it draws, what is the power factor, how much is the kilowatt hour electricity it consumes, what is capacity. And always during this your phase 2, always we focus on what the manufacturer has claimed and what is actual situation. Sometimes manufacturer suppose claim it is a 5 kilowatt motor, and we need to measure whether it is really 5 kilowatt or it is extracting more than 5 or the less than 5. All these are data that we need to validate, and on that basis we will recommend to the company. And all this your data gathering is being done as well as the measurement verification has been done during the phase 2. And phase 3 is the post audit, because initially we got all the information from that your company. Second, during on visit we have taken all the data, and last is we need to do the analysis of all the things. So these are the 10 steps given in that methodology by the Bureau of Energy Efficiency. I will not go in details of this one. So first one is the plan of action. So before going that, we should do the plan of action. So for that, we need to do the walkthrough audit, and where we should develop good relation among all these your officers or heads of this your department, so that they will cooperate during the visit. That was the main important concern during the pre-audit phase. Now during that also, during second step, that is introductory meeting, we'll discuss, we'll share all the information related to that your company, related to that production type of the company with all this, and by that we'll prepare one questionnaire, what data we need to conduct that energy audit. That come under the step 2. Now here during the step 2, we plan for the instruments. So for these are the minimum instruments which required to conduct that energy audit. So this is the power analyzer is the very important instrument as far as the energy audit is concerned. All the electrical related data that can be continuously monitored can be stored with this your power analyzer. It is useful for the single phase as well as a 3-phase. It will give all the types of the voltage, all the types of the current, kilowatt hour, that is electric unit consumption, kilowatt, harmonics, so many parameters which we need to measure. So that is done with this your power analyzer. And generally we install this your power analyzer, connect this power analyzer for 1 hour, 2 hour, or somewhere that is for the full day, where connecting this power analyzer at that your particular locations. That locations are that we need to decide where we want to monitor continuously this all these were electrical parameter for the 24 hours. So accordingly that we are putting, and that novelty of this your instrument, everything you can log, everything you can record, and further it can be analyzed, and on the basis of analyze some inference are taken, and then some recommendations are done to the industry. Now this is anemometer, which is used to measure the flow of fluid. Actually, generally it is being used for the flow of air in the air conditioning system, in the humidification plant. For this, your pharmacy means measure in most of the ducts also you can use this your anemometers to measure, because in pharmacy you need to control, monitor that air quality as per the requirement of the particular manufacturing of that your product. So accordingly, here we'll get idea about the velocity of the air, and then we can calculate the actually how much quantity of air is being flowed. Now another one is the ultrasonic flow meter. In most of the industry, if you go to the industry or even in the colleges, we'll find number of the pumps are being installed. It may be submersible, it may be well type, monopolar, different types of the pumps are there, and water or the liquid is being lifted, transferred from one place to other place, and every manufacturer claims the discharge of the liquid, and that we need to verify. So this is the non-contact type of the, because this you don't need to install inside this your pipe also. Outside you can clamp this your ultrasonic flow meter, and by that we'll get idea about how much quantity of water is being transferred, whether it is at par with the recommendation or the recommended by that your manufacturer or not. That can be done. Now this is another is your flue gas analyzer. This is very important as well as the boilers are concerned, as well as the furnaces are concerned, where coal is being burned in a big way, bagasse is being in big way, or firewood is burned in big way. So here this your flue gas analyzer, that we need to put this your probe in the chimney, and from that we will get details about the flue gas composition of the flue gas, that what are the different gases available in the flue gas. By that we will get NOx, we'll get the SOx, we'll get carbon dioxide, carbon monoxide, and with the help of this flue gas analysis, we can do the audit of the boilers. We'll get the thermal, we can calculate the thermal efficiency of the boiler with the help of the flue gas analyzer. Now this is another is the thermal image. So this your thermal image is used to measure the temperature profile of the surface. Sometimes whenever you stand in front of the any electric motor, any board, or any hot surfaces, sometimes it is very difficult to notice how much is heat transfer by the radiations, because whenever the temperature of any product or the surface is higher than the temperature of atmospheric, automatically by radiation heat is being transferred. So that we need to measure, because for most of the component, most of the appliances, if the temperature goes above that threshold limit, that life of that machine, life of that component get reduced, deteriorated. Even sometimes whenever that electricity flows at higher than the rated of that your cable get heated, and once they get heated for the more time, automatically there are chances of the short circuit kind of the things, but it is very difficult to notice by the naked eyes. So with the help of this your thermal image, we'll get images, actual real image as well as thermal image, and by that we can calculate what is temperature loss, heat loss because of the radiation. Now another one is the hygrometer. This is also mostly used in all these your control units, where we'll get idea about what is the drivable temperature, what is humidity in the air, so that you will get. And this your temperature gun has become popular because of the COVID. We can measure the temperature as single point, and here we can measure temperature at a surface. So these are the minimum instruments which are required to conduct energy audit. In addition, lux meter is there. Some other instruments are also essential, but these are the minimum instruments. So this we need in the pre-stage. Now actually in the phase audit, that is whenever the team enters to the industry or suppose in any college, there we need to gather the primary data. So here actually, suppose if it is a big industry where compressed air is used, we want the flow diagram of the compressor, line diagram of the compressor. If the steam is used, we want the line diagram of the steam. If suppose chilled air is used, chilled water is used for suppose pharmaceutical, wherever it is essential. So all the line diagrams are very essential. So that we need to take from that company and conduct survey and monitoring. Because if you go to, suppose if you go to the pharmaceutical industry, and number of the motors are there, if suppose the motors of the same batch 10 20 motors are there, then it is not necessary to conduct audit for all the motors. Instead of that, you can identify sampling the motors, and there you can measure how much is the consumption of that your motor, and like that has to be done. Now we'll see details about how to read the electricity bill. This is what sometimes we feel that electricity rate of the electricity is very small. That is, this all this your electricity bill, because for energy audit, understanding of the electricity bill or the reading of the electricity bill is very important, vital as far as the calculations are concerned. Because in the invoice, suppose if you take invoice of the coal, so their quantity is given in terms of the tons, and that another certificate is given how much is calorific value of the coal available. On that basis, you can do the calculations for that your coal as well as other types of fuel. But here what happens, now the rates are in the telescopic manner. So suppose this is for the LT residential, so up to 0 to 100 the rates are 346. Always we feel that our energy charges are only 346, but in addition this component is there, billing charges. Because in Maharashtra there are three companies. One is the Mahajanko, which generate electricity. Another one is the which transmit electricity, and third one is which distribute electricity. One is generating, another one is transmitting, third one is the distributing. So generating company only generate electricity, distribution company only distribute the electricity among the different consumers. So in between, the charges required to transmit electricity from the Genco to the distribution is being paid to the transmission company. So these are also charged, depends on the kilowatt hour, means it is one electric unit. So these rates are like this, and there are fixed charges for every electric that consumer. 100 rupees is fixed charge for the single phase. In some of the residential application, we need three phase supply also. So these are the minimum charges. That means suppose if you use only 1 unit, 2 unit, or a 10 unit, you need to pay this or 100 or 340 rupees, and other charges are being calculated on the basis of this. Now even government of Maharashtra has revised charges on the basis of the financial year. So these are charges applicable to 2021. Now similarly for 2022, like this, these are prepared up to 2024. Now this is, I have taken one sample of the calculation. So generally we have done study through this your Mahavitran companies or the Mahadiscom companies. In Maharashtra, almost 40 to 60% of the consumers are consuming that electricity in the range of 100 to 150 electric units. So suppose this is 100 and 120 electric unit, if it is being consumed by the consumer, so that per electric unit, that is per electric unit kilowatt hour, it comes to a 5.42. Otherwise, always we feel that our electricity charges are only 346. But if you calculate all, that is energy charges, billing charges, peak charges, and taxes and all other things, it comes to be a 5.42 rupees. Now, similarly for the commercial buildings, nowadays all the engineering college, pharmacy colleges are coming under this your non-residential or the commercial category. These are the different category. Again, these your categories are depends on the LT2 A, B, C. That depends on the how much is the contract demand. Here it is up to 20 kilowatt rates are different. Between 20 to 50 rates are different. Above 50 the rates are different. Now again here there is no any telescopic. So that rates are fixed from the 0 to any electric unit. So here rates are 7.18 and fixed charges are 450. Earlier it was 100 rupees for the residential, but when it gets shifted to the commercial, the charges comes to be a 415. Now another novelty of this non-residential commercial is of the time of day tariff. Even for the college also that time of day tariff is there. All this your distribution company gives some rebate benefit if you use that electricity at a non-peak period. So this is called as a time of day, and most of the industries are taking advantage of this. Suppose here if I take example, that is for the above 50 kilowatt, rate is 12.95. If suppose if you use the electricity between night 10 to morning 6, there is electricity reduction is 1 rupees 50 paisa. So this much is get reduction from this 12.95. And even for the peak period, morning 9 to 12 and evening 6 to 10. So here rates are extra, that is 12.95 plus 80 paisa that we need to pay if I use the electricity from 9 to 12. And if I use electricity between evening, because evening is the peak period, highest electricity demand is at the evening, that from the 6 to 10. So additional 1 rupees 10 paisa that need to pay to the industry. So all this your industry, that administrator or the energy manager has to use wisely, consume electricity as per this your TOD pattern. Now another industry category, their rates are different. Now here you can see here the commercial rates are higher as compared to the industry, as compared to the residential also. Now this is power factor. Now even that they are getting benefits for the power factors. Now this is another category for the HT level. Earlier we have seen for the low tension, now this is the high tension. Now again the demand charges are increasing and rates are also different, and here also they are getting time of day, the tariff. Now this is for the government colleges as well as that is public services, the rates that you need to understand what are the different components, how to read, how to calculate this electricity. Now again that electricity has number of the component, one is the maximum demand, another one is the contract demand, and the sanction load. This we need to understand on the basis of there are some points in the electricity bill. Now suppose for example this I will explain with the help of the that bill also. Now even suppose the industry is using the bulk consumption, if the industry has the bulk consumption of the electricity, even this your distribution companies are giving a rebate to that company. If suppose they are using electricity more than 1 lakh unit, that is 1 lakh kilowatt hour, they will get 2% discount in that bulk rebate in that electricity bill. Now here this is one electricity bill. This is purposely I have taken in order to understand how the electricity bills are being calculated. Now see here, this is one component is a contract demand, 750 of the contract demand. So this is a demand, this is the agreement between the distribution company as well as that a consumer or that industry person. This is the agreement between that they will provide electricity up to 750 kVA of this your demand. And out of this, suppose even they can use electricity or not, but at least they have to pay this much charges, this 60%. Again, this 60% it again varies every year as per that your their agreement. So minimum, suppose they got a contract demand, this much is contract between the distribution as well as consumer, 750. Whether the consumer uses or not uses, every month they have to pay this was minimum charges for the 450 into that whatever rate decided for that particular category. If suppose sometimes if they consume more than 750, anywhere in between that month for the 30 minutes, because they used to calculate for every 30 minutes, anywhere once it comes spike goes above this your 750, then they have to pay extra charges, excess charges for the maximum demand. So this is the sanction load, because how much that appliances are connected, that all come under this your sanction load. So here all the details are given. This category is also given for this your electricity bill. Now here you can see how the electricities are being calculated. So this your demand charges. So this is the demand charges. Now that company has utilized 527 kVA because they are already that contract demands was 750. So it is below the 750. So this your 525 multiplied by 3 432. These are the minimum, that is fixed charges or the demand charges for this company. Now, as it is the industry, so the wheeling charges are different. That is 56 paisa per unit. Now here unit is kVA. For all our residential, we pay in terms of this your kilowatt hour. But for all this your HT consumers, they have to pay in terms of the kilowatt ampere hour. Now the difference between kilowatt ampere hour, that is for the power factor. If power factor is 1, that means both are equal. If power factor is less, that means kilowatt hour is less. But this industry has to pay on the basis of this kVA. Now here you'll find this your TOD. Now this industry is wisely using this electricity during that off period. So they got a benefit around 62,000 rupees. So like this we need to read, we need to understand, and being as energy manager or auditor, first we need to understand and we need to analyze this your electricity bills. And if you analyze properly electricity bills, we can suggest, we can recommend that industry owner to save electricity, save energy cost by some modifications. Now here you can see, as per this your chart, the rates are 6.96 per kVAh. This is per kVAh, and by considering this 432, actually per kVA it comes to be 9 rupees. Now you can imagine how much is the difference, how it goes, and that goes because of the hidden charges in the. Now next step is, during audit, conduct a detailed trial test for a selected, because for some of the appliances, some of the equipment, we need to conduct trial for the 24 hours also. Because suppose the compressor is there, boiler is there, air conditioning appliances are there. There we need to understand for what period we want to take the trial or the readings of this. So this come under this, and we need to do the analysis of energy. That means energy and material balance. If you take the example of this your pharmaceutical this industry, what is the raw material for the pharmaceutical industry, what is the finished product or the tablets of that industry or the liquid syrup of the industry. So how much raw material comes and how much is the finished good or the product, and the difference is the wastage. That we need to understand as far as the material is concerned, and how much energy comes to that industry for that your process, and how much is being utilized, and how much goes as wastage in terms of the heat energy, in terms of the electric energy. That actually we need to understand, and on that basis we'll come out with the energy loss as well as the wastage for that particular process. And the next step is identification and development of energy conservation opportunities. So far we have collected all the electricity bill, we have collected invoices, we have done analysis of the electric bill invoices, we took trials on the different machines, we take the measurements of all these appliances, and on that basis now we have to prepare we have to suggest how to conserve the electricity. So this brainstorming session starts from the this is step 7, and it is called as energy conservation opportunities that we need to decide. Now next is cost benefit analysis. Suppose if you recommend anything to replace to any manufacturers, immediately they will ask what is the rate of return for that investment. Always all this your manufacturer, all this your industry persons, or the commercial owner of the commercial building, always they ask about what is the return on investment. If I invest, how much period it need to get a payback of all this money, that amount, that need to be understand. So that cost basis analysis that has to be done, and finally reporting and presentation to the top management. Once we prepare all this your recommendation with the cost basis analysis, that we need to present in front of this your top management, and as during the discussion some changes need to be done as per their expectations as well as per our calculations, and finally that report has to submit to the industry or the top management. So this is one photograph or snap of the thermal image. Now this is a real image, and this is the thermal image. If you go, this is the image of the sugar factory. If you go to the sugar factory, you won't notice that is this all the pipes are of this temperature. But if you stand in front of this, you will notice that heat is coming by the radiation. But actually it is very difficult to identify what is temperature at what quantity that heat is being lost. So with the help of the thermal image, you will get this real image as well as this thermal image, and then we can calculate how much is lost, what type of the insulation is required. All these things can be done. So these are the different images which can be taken from the thermal image and real image. And last step of the sure detailed energy audit is the implementation and follow-up. Suppose if you prepare the report, presented to the top management, and if it has been submitted, that much is not work of the energy auditor. Energy auditor has to take the follow-up till the implementation of all the your suggestions made by that energy audit. And for that we have to prepare action plan, schedule for implementation, and monitoring as well as periodic reviews also very important. Now I'll take one case study of a residential building. It is very simple case study. Now suppose this is any independent bungalow, or you can consider any flat which consists of the 2-bedroom hall and the kitchen. 2-bedroom hall, kitchen, and all this your utility. It consists of the tube light as well as a fan. So total it consists of the 4 tube light and 3 fans. Generally we use electricity, different types of the energy in the residential application as electricity, tube light, fan, refrigerator, cooler, all this mobile charger. And thermal, we need thermal energy or heat energy for the cooking, water heating, as well as ironing. So these are the majorly two types of the energy which we use in the residential applications. Now suppose if I take the example, this is the inventory. By considering that building, I have taken the total uh, 4 tube lights of 40 watt. Actually the tube lights available in the market are of the even that goes up to the 52 watt. Even if you say that this is a 36 watt that tube light or the pipe, it consumes the 40. So I have taken as a 40 watt tube light, and total number of the appliances are 4. Daily we are using suppose approximately 6 hours per day. So total per day we are consuming as far as the tube light as a 960 watt hour, or if you consider it as a electric unit, it is approximately 1 electric unit. Similarly, generally we are using fan of 1200 mm. So the wattage of the fan is 65 watt. There are 3 fans. Daily usage is 10 hour. Nowadays we are using more frequently for more period. This usage is more for the fan. So total electricity consumption per day for the fan, it comes to be 1950 watt hours or 1.9 electric unit. Suppose we are using TV of 32-inch, which has a wattage of 50 watt, one number, daily usage 6. So it will consume around 300 watt hours. And one refrigerator, this is I consider as an old type of the refrigerator, non-star level. So it has a capacity of 210 liter. So per year it consumes around 385 electric. This is electric unit per year. So per day we are consuming almost 1 electric unit or 1055 watt hours of this electricity. All total comes to be 4265. If I convert to the month, so for this month we are consuming for this 4 tube light, 3 fan, 1 TV, and a refrigerator around 128 electric units. So this comes as a electric kilowatt hours. Okay. Now we'll see how to switch over or how to do audit. Now this is what in audit, initially if you want to do the audit for your home or the any residential building, initially you have to collect a 12-month electricity bill, that you need to do the analysis of the electric bills, and then you have to check the inventory inside that room. So as per our this, suppose this is the inventory with 4 tube light, 3 fan, 1 TV, 1 refrigerator. Now we'll see that electricity, that tariff already we have seen. So up to 100 unit, that is wheeling charges are 1.45 and energy charges are 3.46. Above 100 and up to 300, so wheeling charges same, but these charges increases. So accordingly we have calculated that comes to be a per electric unit 5 rupees and 52 paisa. Now we'll try to switch over, change that all energy intensive appliances to the energy efficient appliances. So as these are this will give you idea about what are the appliances, electric tube light or bulbs available in the market. Earlier we were using this were incandescent lamps, but nowadays nobody is using this incandescent lamps. Now it has been replaced by the CFL. Now again we are switching towards the LEDs. Okay, and these are the varieties of the fan. Now as per this your standard and labeling, now these all these your appliances, bulb, tube lights are available in the market from the first single star to the 5 star. Now this is these all these your bulbs are recommended or advertised in the market on the basis of the lumens per watt. So this is like a star level available for this or all these your tube lights, and this is for the 4 star. Even we can see the, suppose if it is a star 1, that means the lumens efficacy or lumens per watt, it should be between 79 and 90. It should be between 79 and 90. Even it has a freeze. Now this star 1 is not available in the market. Now suppose if I take example of this your 4 star, so for the 4 star, that lumen should be between 120 to 135. So here it is given 108. That means every year this your Bureau of Energy Efficiency enhances the star limit. That means suppose even if you go to the market and if you want to purchase the tube light, and if it is available with the 5 star, the different manufacturer have the same star level, but this your output might be different. Here it is shown that it is more and above one equivalent above this your 135 lumens per watt. So whenever you go to purchase any appliances, there you need to check the star label, how many stars are there, as well as validity of that label and the range of the label, and on that basis the costs are there. So generally, general thumb rule is that all these your LEDs available in the market, per watt it gives more than 100 lumens. So easily we can shift or you can conserve around to two-thirds of the electricity as compared to CFL as well as your bulb. Now here this is what already I had mentioned about the power analyzer. If I use the power analyzer to read the consumption of this your tube light, here it shows that this tube light is consuming 43 watts of the power. This is 0.043, that means 43 watts of the power. And this is the total details about the power analyzer, the photo. Now suppose if I want to shift that energy intensive that tube light to the energy efficient tube light. So suppose earlier I have seen that, or I have considered it as a 40 watt. So to total there are 4 tube lights. So total comes to be a 160 wattage. Now daily I'm using for the 6 hours. So annual working hours comes to be a 2190. So annual consumption for this working hour by considering this total wattage, that comes to be a 350 kilowatt hour, or it is the electric unit. This kilowatt hour means it is nothing but electric unit. Now suppose the same all the tube lights if I replace by the LED tube lights. So LED tube lights available in the market are with 18 watts. So the total wattage comes to be 72 as compared to this or 160. So naturally, so annual energy consumption for this 4 tube light is 150 electric unit as compared to the 350. So my saving comes to be a, this electric unit saving comes to be a 192 electric unit. So this much or kilowatt hour saving. Now already I have calculated tariff for my that residential consumption. It comes to be 542. So monetary saving comes to be 1,000 rupees. And nowadays these tube lights are available in the market with in the range of the 200 to 300. So suppose if I consider it as a 225 rupees, so total my investment would be only 900. And the payback is calculated investment divided by the saving. So investment is 225 and my saving, yearly saving is 1,000 rupees. So within 1 hour that all my investment get recovered, and from the next year onward this much is saving from the tube light. So like that we need to calculate. This is very simple calculation. Similarly we do calculation for the electric motor, boilers, furnaces, compressors, air conditioners, like this. So like this we need to do the analysis. Now similarly we'll go for the other appliances, that is the fans. These tube lights are marketed in with the lumens per watt. Now similarly these your fans are advertised on the basis of the service value. It is advertised on the basis of the service value, and service value is nothing but how much air is being distributed inside the room per watt. So always that we need to calculate per watt how much CFM, or it is a CMM, because different types of the units are being used. So it is a cubic meter per minute. So accordingly stars are given. So suppose this is the 3-star label pasted on this your any one fan. So here service value given is 5.2. Now here you can see service value for the 3-star is starts from the 5 and up to 5.5. That means 3-star appliances available in the market from the 5 service value to the 5.5 service value. So what it represent, the significance of this is, if suppose if I go to this value 5.5, so this more quantity of air will be distributed inside the room per watt. So always it is better to purchase this fan with the higher service value, even suppose if you need to pay some extra charges. Even we have done some study with the non-star fan as well as a 5-star fan. And suppose at non-star, if I start with the first single speed or first speed, so it consumes 18 watt, 5-star fan consume only 3 watt. Similarly at third speed, it is a 46, it is a 12 watt, and for the highest it is 67 and 28. So if I compare only this speed, so the yearly saving is around 100 electric unit. So this is the huge saving. Here you can this is calculated only for the single fan. But for the industries, they are using thousands, hundreds of the fan in the industry. If you multiply it by the 1,000 fans, so the saving is huge, and investment of the payback is very less. So similarly, with the help of the power analyzer, we have done this your measured that actually consumption. So for that particular fan, it consumes around the, so it is a sir. मी एक कंक्लूड कर लाईक करून टाक. आवाज येतोय आता? हा. चला 5-10 मिनिट. Okay. Now similarly, you can purchase this fan which are available in the market. All this your data is available from the BE Star website, bestar.com. So from that you will get all this your data information from the website. You can anytime download. Similarly, for the fan, you can calculate how we did for the tube light. Now this is for the air conditioner. Also for the air conditioner, details are given. Now air conditioners are highlighted on the basis of the energy efficient ratios. Nowadays, for the Indian climatic conditions, they are treated as a ISER, Indian Seasonal Energy Efficiency Ratios. So always while purchasing the air conditioner, we should measure what is the value available on the nameplate. That we need to read that what values are available on the nameplate, and on that basis you can purchase. The value is higher, that means it is a energy efficient, and that values go on higher side on the basis of the star labels. Now suppose this is one table which give you idea about, suppose if it is a single star, it has compared with the star. So every star here the unit cost or the consumption go on decreasing. So that also we can see these air conditioners are available in the market. So you can go through this your star bestarlabel.com and you can compare, you can download all this your data. Similarly for the fan, this is TVs are also available. So the TV, this data is it is pasted on the with the star label, as here it shows that 88 kilowatt hour per year. So this is for the 30 to 50 watt. This is so. Now again, this data, it depends on the standby mode as well as on mode. How so this data is available. I will finish all this thing. So suppose this is the, these are the size, or if I take the example of this your, suppose this is a 50-inch tube light, that is TV is there. For the 50-inch TV, so standby mode, even suppose that TV is off but it is in the standby mode, it will consume 0.39 wattage, and when it is on mode it consumes 58 wattage. So that also you need to understand. So whenever you don't want to use the TV for the more period, it is better to off from the main switch. So that care has to be taken. Now similarly for the refrigerator also, so that is given for the refrigerator. So if it suppose I have taken the example of the 10 that volume capacity non-star, it will consume 385 electric unit per year, and 5-star it will consume 157 electric unit per year. So that saving, that these all the tips are given how to conserve. So these are some of the method steps which are given on the website also. So finally I will come to the conclusion. So whenever here I replace that energy efficient, all this your tube light initially from 40 to 18 watt, I replace that 65 watt fan to the 28 watt. This comes. TV I replace with the 5-star, as well as refrigerator I replace to 5-star. So it comes to be per year consumption, sorry, per month consumption only 55 electric unit. Earlier it was a 128 electric unit. So if you just at home, if you do audit and if you replace all energy intensive appliances to the energy efficient appliances, only here we have replaced fan, tube light. Here with this also, per family you can per day you can conserve around 2 electric unit. And if suppose from your college around 2000 students come together, family come together, and they decided, so even they decide to conserve only one electric unit, so that would be a daily 2000 electric units. So that's a great huge amount of electricity that you can conserve, and that is a substitute as good as around 750 kilowatt of this your power plant. So per year you can conserve this much electricity. So we'll stop here, and if you have any question answers, sir, because further so
Yes,
many
sir.
are there. Hello, Sonan sir.
Yes, sir. Yes, sir. Any participants, any students, any faculty, do you have any questions? You
Hello.
may. Yes, sir. Am I audible, sir? Hello. Am I audible, sir? Hello. Am I audible, sir? Hello.
Audible, sir.
Okay. Yes. Thank you, sir. Any questions from students?
We'll stop it. If they have any doubt, otherwise we'll stop. No issue. Huh? Okay.
If any students have any doubt, faculty or participants, you may ask the questions. Otherwise, we will proceed for the end of the session. Madam, can we click the photo? Prinkle madam. Prinkle madam.
Yes, sir.
Participant students and all the faculty members, please switch on the videos. Yes. Thank you. Now we'll come to the end of and vote of thanks. Thank you all. It is my great privilege to propose a vote of thanks. I very much thankful to today's guest and speaker, Dr. Sanjay Khot sir, BE accredited energy and principal, Sharad Institute of Technology, College of Engineering, Yadra, Itzalkar, for delivering a wonderful session on energy conservation and audit. Sir, this session is definitely useful and motivational for our students and faculty members, where we can conserve the energy by different ways.
Hello.
I thankful to Maloji. I thankful to
Hello.
Maloji Raje Chhatrapati, honorary secretary of all India Memorial Societies, and an entire management for encouraging to this webinar. Am I audible, sir? Madam? Twinkle, madam?
Yes, sir. Yes, sir.
Yes, yes. I am thankful to Dr. Ashwini Madgulkar, madam, principal, AISSMS College of Pharmacy, for motivating that faculty and students. I am thankful to Central Media team for support. I also thankful to Dr. Santosh Gandhi sir for guidance to coordinate this webinar and all the backgrounds to make this webinar to be successful. At last, I am thankful to all teaching staff and teaching staff, students for actively participating this webinar to make this a wonderful session.
Stop video.
Thank you once again.
Thank you, sir.
Yes, thank you, sir. Thank you very much.
Thank you, sir.
Yes. Shall we stop it here now, madam?
Yes, sir.
Yeah, okay, yes, madam.
हॅलो. हम्म.
Ha, yes, sir.
येत नाही आवाज
Yes,
येत
sir. Hello, you are audible, sir.
नाही. जर संपलं वाटतं संपलं ते. हम्म. काय तर प्रॉब्लेम असेल. हम्म. आल्यासारखं झालं त्यांचं. हम्म. हम्म. काय झालं चल. काय तर नेटवर्क इश्यू दिसतो परत. असं नाही आलं. ठीक आहे की असं आलं नाही ते. चल जर त्यांचा प्रॉब्लेम झाला हा जरा हे होतं नाही ठीक असं काय अडचण ना. ओके सर थँक्यू सर थँक्यू.
Hello, sir. Am I audible?
Yes, sir. Thank you, sir. Thank you.
Thank you, sir.